Hello guys, and welcome back to this channel. In today's video we are going to learn how to rationalize a set. Now if you are new here, do well to subscribe to this channel, like the video and share the video with your friends. Now when simplifying fractions containing a set at the denominator, it is usually more convenient to make the denominator rational to avoid division by a decimal. Now the process of making the denominator rational is what we call rationalization of sets. So for instance, let's say you are given the expression 1 over the square root of a. Then we can rationalize this expression by multiplying top and bottom by the square root of a. So we have 1 over the square root of a, and then we multiply top and bottom by the square root of a. Now 1 times the square root of a is equal to square root of a, and then square root of a times square root of a is the square root of a squared. So we have root a divided by, now the square cancels the square root, so we have a. So we've been able to rationalize this expression 1 over the square root of a to get the square root of a divided by a. Now let's solve some examples. So for the first example, let's rationalize the expression 1 over the square root of 3. Now to do this, we are going to multiply top and bottom by the square root of 3, or the numerator and the denominator by the square root of 3. So this is equal to, we have 1 over the square root of 3 multiplied by the square root of 3 over the square root of 3. Now 1 times root 3 is root 3, and then root 3 times root 3 is root 3 squared. So we have root 3 divided by 3. So for the second example, we have 4 over root 7. Now let's do this together. So let's rewrite the expression 4 over root 7, and then we multiply top and bottom by root 7 and then root 7. So we have 4 times root 7, which is 4 root 7, and then we have root 7 times root 7, which is root 7 all squared. So we have 4 root 7 divided by 7. Now let's talk about conjugate sets. So now let's talk about conjugate sets. So given the expression a plus the square root of b, then the conjugate of this expression will be a minus the square root of b. Now the difference between the two is that if you are given this expression, to find the conjugate of it, then basically you are going to change the operation in between the two terms, so that a plus the square root of b has a conjugate a minus the square root of b. Now let's say you are given the expression square root of 2 minus the square root of 3. Then the conjugate of this expression is equal to the square root of 2 plus the square root of 3. If you are given the expression 2 root 5 plus 4 root 3, the conjugate of this expression is 2 root 5 minus 4 root 3. So having this in mind, let's solve some examples. So for the first example, we have 1 over the square root of 3 minus 1. Now how do we simplify this expression? Now to solve this expression, we need to multiply top and bottom by the conjugate of the denominator. Now the conjugate of root 3 minus 1 is root 3 plus 1. So we are going to multiply both the numerator and the denominator by root 3 plus 1. So now let's solve together. So we have 1 over root 3 minus 1 times root 3 plus 1 divided by root 3 plus 1. So we have 1 times root 3 plus 1. So that's going to give us root 3 plus 1. And then for the denominator, we pick one term and then multiply by root 3 plus 1. And then we pick the second term and also multiply by root 3 plus 1. So we have root 3 multiplying root 3 plus 1. And then we have negative 1 multiplying root 3 plus 1. So we have root 3 plus 1 as the numerator, and then let's simplify the denominator. So root 3 times root 3 is root 3 all squared, plus root 3 times 1 is root 3. And then we have negative 1 times root 3, which is negative root 3. And then we have negative 1 times 1. So that is negative 1. So here we have the square root of 3 plus 1 divided by, now root 3 squared is 3 because the square cancels the square root. So we have 3. And then the square root of 3 minus the square root of 3 is 0. And then we have negative 1. So we have 3 minus 1. Okay, so the square root of 3 plus 1 divided by 3 minus 1 is 2. So we have 2. So we can split this to have the square root of 3 divided by 2 plus 1 over 2. So this is the final answer. Now let's solve the second question. So for the second question, we are going to rationalize 4 over root 7 minus root 3. So as usual, we are going to multiply top and bottom by the conjugates of the denominator. Now the conjugate of root 7 minus root 3 is root 7 plus root 3. So now let's multiply top and bottom by root 7 plus root 3. So we have 4 divided by root 7 minus root 3 times root 7 plus root 3 divided by root 7 plus root 3. So let's multiply across. Now 4 times root 7 plus root 3 is 4 outside, and then we have root 7 plus root 3 inside the bracket. So here we also have root 7 multiplying the whole of what's in the bracket, that is root 7 plus root 3. And then we have negative root 3 multiplying root 7 plus root 3. So we still have 4 times root 7 plus root 3 all over. Now root 7 times root 7 is root 7 squared. So root 7 squared is equal to 7. So we have 7. And then here we have root 7 times root 3, that is root 21. And then here we have negative root 3 times root 7, which is negative root 21. And then we have negative times positive is negative. And then we have root 3 times root 3. Now root 3 squared is 3, so we have 3 here. So we still have 4 root 7 plus root 3 in the bracket divided by, now the square root of 21 minus square root of 21 is 0, so we have 7 minus 3. Now 7 minus 3 is 4, and then 4 cancels out 4, so we have the final answer to be root 7 plus root 3. That's very simple. Let's solve our third example. So for the third example, we are to express 4 plus root 5 divided by 3 minus 2 root 5 in the form of p plus q root 5, where p and q are rational numbers. So to solve this, first of all, let's write down the expression. So we have 4 plus root 5 divided by 3 minus 2 root 5. So as usual, we are going to multiply top and bottom by the conjugate of the denominator. So that is 3 plus 2 root 5. Now let's multiply across. So we have 4 multiplying 3 plus 2 root 5, and then we have plus root 5, 3 plus 2 root 5, all divided by 3 into brackets 3 plus 2 root 5 minus 2 root 5 times 3 plus 2 root 5. So we have 4 times 3, which is 12. And then 4 times 2 root 5 is 8 root 5. Root 5 times 3 is 3 root 5. And then root 5 times 2 root 5 is 2 into brackets root 5 squared. Now the coefficient of root 5 is 1, so 1 times 2 is 2, and then root 5 times root 5 is root 5 squared. So we have that divided by, now 3 times 3 is 9, and then 3 times 2 is 6, so we have 6 root 5 minus, now 2 times 3 is 6, and then root 5, and then 2 times 2 is 4, and then root 5 times root 5 is root 5 squared. Now let's simplify further. So we have 12 plus, now since we have like terms here, that is root 5, we can add the two terms. So we have 8 plus 3, which is 11. So that is 11 root 5 plus, now root 5 squared is 5. So 5 times 2 is 10. So we have 10 divided by 9, and then 6 root 5 minus 6 root 5 is 0. So we have 9 minus 4 times 5, because the square cancels the square root. So we have 12 plus 10, which is 22, plus 11 root 5 divided by, now negative 4 times 5 is negative 20, and then 9 minus 20 is negative 11. So we have negative 11 here. So we have 22 plus 11 root 5 divided by negative 11. So let's split this expression. So we can have 22 divided by negative 11 plus 11 root 5 divided by negative 11. So that is going to be negative 2 minus 11 cancels out 11. We have negative root 5. Now let's go back to the question. According to the question, we are to put the expression in the form p plus k root 5 so that we can find the value of p and the value of q. Now we have this expression in this form. So comparing these two expressions, we have p to be equal to negative 2 and then q to be equal to negative 1. The coefficient of the square root of 5 is negative 1. So this is the value of p and q. So let's solve our last example. So let's solve our last question for today. We are going to express 8 minus 2 root 6 divided by 2 root 3 plus 3 root 2 in the form m root 3 plus n root 2, where m and n are rational numbers. Okay. So like we did for example 3, we have 8 minus 2 root 6 divided by 2 root 3 plus 3 root 2. So we are going to multiply top and bottom by the conjugate of this expression. So that is going to be 2 root 3 minus 3 root 2. And then we have that divided by 2 root 3 minus 3 root 2. So next we are going to multiply across. So we have 8 into bracket 2 root 3 minus 3 root 2 minus 2 root 6. We have 2 root 3 minus 3 root 2 divided by 2 root 3 multiplying 2 root 3 minus 3 root 2 plus 3 root 2 times 2 root 3 minus 3 root 2. Now we have 8 times 2 root 3, that is 16 root 3. We have 8 times 3, which is 24. So we have 24 root 2. Now we have 2 times 2, which is 4. And then we have root 6 times root 3, which is root 18. And then negative times negative is positive. We have 2 times 3 is 6. And then root 6 times root 2 is root 12. So divided by, now we have 2 times 2 is 4. And then root 3 times root 3 is root 3 squared. So root 3 squared is 3. So we have 4 times 3 minus, we have 2 times 3 is 6. And then we have root 3 times root 2 is root 6 plus 3 times 2 is 6. Root 2 times root 3 is root 6. We have minus 3 times 3 is 9. And then root 2 times root 2 is root 2 squared, which is 2. So we have 16 root 3 minus 24 root 2 minus 4, and then root 18 is 3 root 2. So if you have root 18 is equal to root 2 times root 9, and then root 9 is 3, so we have 3 root 2. So that is 3 root 2 plus 6, and then root 12, square root of 12 is also the square root of 4 times the square root of 3. Okay, so we have 2 root 3. So we have 2 root 3 here divided by 4 times 3 is 12. So we have 12, and then negative 6 root 6 plus 6 root 6 is 0. So we have negative 9 times 2 is 18. So we have negative 18. So we had 16 root 3 minus 24 root 2 minus 4 into bracket 3 root 2 plus 6 into bracket 2 root 3 divided by 12 minus 18. So we are going to have 16 root 3 minus 24 root 2 minus, now 4 times 3 is 12. So we have negative 12 root 2, and then 6 times 2 is 12. So we have 12 root 3 divided by 12 minus 18 is negative 6. So we can add 16 root 3 and then 12 root 3 because they are of like terms. So 16 plus 12 is 28. So we have 28 root 3. And then we can subtract negative 24 and then negative 12. So negative 24 minus 12 is negative 36. And then we have root 2 divided by negative 6. So let's split this expression. We have 28 root 3 divided by negative 6. And then we have negative 36 root 2 divided by negative 6. Now 2 goes into 6 3 times, and then 2 goes into 28 14 times. So we have negative 14 over 3 root 3, and then negative cancels out negatives. So we have plus, and then 6 goes into itself once into 36 6 times. So we have 6 root 2. So this is the final expression. Now according to the question, we are asked to leave our expression in the form m root 3 plus n root 2. And then we also have our answer to be negative 14 over 3 root 3 plus 6 root 2. So comparing, you realize that m is equal to negative 14 over 3, and then n is equal to 6. So we have m to be equal to negative 14 over 3, and then n to be equal to 6. So that's it for today's video. Do well to like and share among friends. Hope to see you in my next video. Bye bye.